Hey everyone, this is a video for Mini Project 5.3. So for a majority of this video, we'll talk about how to set it up, linear programming questions, and I will actually solve them with Desmos. Okay, very interesting, nice tool to do this sort of shading, get your points. Okay. So it says here this furniture company has two plants. And in one day, plant A can produce the lumber required for 18 tables and 56 chairs, and plant B can use to produce 26 tables and 47 chairs. In this run, the company needs X amount of tables, so 227, and 486 chairs. If it costs 1,092 per day to operate B and 1,006 to operate A for that, 1,006 for B, what is the minimum cost of the run? So let's set up our constraints. All right. So pretty much we know that, the basic ones, X and Y, and let's say X is the number days for A. So this is for plant A, and Y is the number of days for B. So let's do an equation that relates these table totals. So 18 is with A, so 18X plus 26Y is greater than or equal to 227. And let's do one that does the chairs now. So 56 chairs. So 56X plus 47Y is greater than or equal to 486. And then it says the cost. So remember, this is your objective function. Remember, your objective function is either you're trying to get a min or max of something. So we want the minimum cost here. So we get all our points that intersect our constraints, our shaded area, right? And then our objective. So for A, it's 1,092 per day, plus B is 1,006. And this is our cost. Right? So every corner point we're going to have to evaluate at this. Okay. So let me write some of these down. Right, so let's go over to Desmos. So we have X is greater than 0. We have Y is greater than 0. We know that we're in the first quadrant. And we have 18X plus 26Y is greater than or equal to 227. So you see we have now this point and this point here. It's hard to see to draw on there, but you see the 2 points that labeled this point and this point would be our 2 points we would be concerned with, because that has all three of the shaded parts that we need. And then the last one, 56X plus 47Y is greater than or equal to. So we see here that this would be one value, this would be another, and that would be the other one, because those are the three in the complete shaded area. Okay. So our objective function, and so let me indicate these points again. So write these down, take a photo of them. Okay. And let's see what our objective function is. So you can do this a few ways if you'd like. So since our objective function is based on X and Y, you can write it like this. C parentheses, x, comma, y equals 1092 plus, I forgot my x on that, 1006y. So that's just defining your objective function. So, and then now if we do, let's say for that first point, we had to do it at x was 0, comma, y was 10.34. We get that it's 10,402. Okay. Now if we look at the next one here, so we're just doing function notation, evaluating each one. So 3.225, comma, 6.489. We get that it's 10,058 for that second point. And then for the last point here, 12.61. We get 13. So we see that the middle one here is that 10,058 and 68.68, right? So if we go back, we see that what is the minimum cost? Round to the nearest cent. So we see that using Desmos, that cost at 3.225 for X and 6.498 for Y gave us 10,058 and 69 cents. So that is the minimum cost that we have here. Okay. So on to the next question that we have. So an investor has 1,200, or not 1,200, 112,000, and to invest in bonds. Bond A yields a 5% average. Bond B yields a 8.3% average. The investor requires at least 3 times as much money invested in A as in B. You must invest in these bonds to maximize your return. What is your objective function? Right? So how much do you get back out, right? So if I put X in bond A, then I'm going to get 5% of X. If I put Y in bond B, I'm going to get 8.3% of Y. So what I get out is right here. That's, you're just looking at what's your objective function there. So the third question is kind of previous thing, but now what is the maximum return? Okay. So I have 453,000 to invest in bonds, right? So if X is bond A and Y is bond B, then X plus Y has to be less than or equal to the total amount of money I can invest. Okay. And we know they have to be positive, right? So I can write X and Y have to both be greater than 0. And then we need to think about, it says at least 4 times as much money be invested in bond A as bond B. So if A is X, then 4 times as much money be invested in A as B. So if B is Y, then you write it like this. So A is at least, so do you think Matt requires that at least 4 times as much money be invested in A as B. So the amount in A is at least 4 times the amount in B. Okay. You invest these to maximize your return. So I want my yield to be the largest. So these are your constraints here. Right? That x is greater than 0, y is greater than 0. Those are 3 and 4. So your objective function is, well, the amount of money in x you'll get 9.2% back from. So and y you'll get 5.4, so 0.054% back. And this equals your return. So we could do a very similar thing that we did before in Desmos. So take a picture of any of your equations that you need, and let's go over to Desmos. So we see here, I'm just going to start deleting some of these. All right, so we know that x is greater than 0, y is greater than 0, because we have to have money in each account, at least something non-negative. And then we have that our investment has to be, so it's pretty large, so we can zoom out quite a bit and kind of see where this triangle is. Okay, so we see the triangles right there. Okay. And then the last one, x is at least 4 times the amount in y. So we see we have this point, which is 0, 0. So obviously that's not going to give you your money back, right? You're not going to get anything. We have that point, and we have this point. So it's either going to be one of those 2 points on the right. Okay. So let's take a picture of these. So we said that our return, so I'm just going to use R, was what? So we said it's 9.2%, so 0.092 of x plus 0.054 of y. So let's evaluate those 2 points. So just for sanity, if you do the origin, which is one of those corner points, you'll get that you don't get anything back, which makes sense. You're not investing any money. If I do the other corner point, the one on the x-axis, if I invest all the money in the first account, I get 41,676. Now, if I invest all the money in the other account, or not the other account, if I do the break it up a little bit, so 362,400, comma, I get something smaller, right? So it just so happens that investing everything in the first account is the way to go here. And why is that? Seems like bond B just gives you more money. So in this case, what is your maximum return? It would be that interest that I make. So the 41,600. Right? 41,676. I don't think there was any cents. Nope, no cents. So that is your. So in some cases, you might actually have one of those points. Okay. Now this would be a little bit different if some of the wording was different. Instead of at 4 times be invested in A as B. If it was in B as A, then that would change your result drastically. Okay. So I hope you enjoyed this video. As always, if you have any questions, email your instructor. Thanks. Hey everyone, I did leave out this question. I do apologize. So for question 4 on 5.3, we see that we have the furniture company. We have some details here. And I just want to know the objective function for this. Okay, so if you read through it, it's just like the plant production of tables and chairs. So pretty much I'm just looking for the objective function. So for the first plant, it was $8.75 per day. For the second plant, it's $8.50. So that would be leading to my objective function. Remember, because I'm looking for the cost, right? I want to minimize the cost. So my objective function has to be the cost to run each plant. And all the other information would be to get your constraints. So we see here we need 875x and 850y. So this one right here is it. Thanks.